This time we're going to do linear programming. Okay, so let's look at this problem. NASA needs to decide which item should be loaded in the space shuttle. Okay, so the space shuttle can carry up to 2,600 pounds. The weights and benefits are available. So these are the weights of each item and the benefits of each item. So you have item 1 to item 7. These are the weights and these are the benefits of each item. Okay. So the quantities of items 1, 2, 3, and 4 are unlimited. Okay, so if we let x1, x2, x3, x4 are the number of items of item 1 to 4 respectively, then we can say that x1 to x4 should be integer. Okay, so it's unlimited. Okay. Now items 5, 6, 7 are only 1, and so that means that 5, 6, 7 must be binary. x5 to x7 must be binary. And then we should satisfy this constraint as well. Okay, so right, so we should satisfy this constraint here. So right, so we have to think about how to do this. Yeah. Okay, so the first one is that at least one item from each group must be loaded. Okay, so from group 1, item 2, 5, and 6. Okay, at least one of them should be loaded. So that must be easy, right? So they should be like, x2 plus x5 plus x6. Okay, at least one item. So should be from each of the following groups. So it should be greater than or equal to 1. Okay. And then at least one item again of items 1, 3, 4. So x1 plus x3 plus x4 must be greater than or equal to 1. Okay, so that takes care of that. Now the weight constraint, I will do that later, right? So next, if item 7 is not loaded, at least one item 2 must be loaded. So if item 7 is not loaded, at least one item 2 must be loaded. So that means that if x7 is equal to 0, okay, if x7 is equal to 0, that means it's not loaded, then x2 must be greater than or equal to 1. So that is your clue there. So x2 must be greater than or equal to 1 minus x7. Yeah. Okay. Then x7 is 0, right? It's not loaded. x2 will be greater than or equal to 1. Yeah. Next, if item 7 is loaded, item 6 must also be loaded. So if x7 is 1, x6 must also be 1, right? So this means that x6 must be greater than or equal to x7. Yeah. Okay, must be greater than or equal to x7. Okay, so if this is 1, then x6 will necessarily be 1 because this is greater than or equal to. But if item 7 is not loaded, x7 is 0, so x6 can still be 1 or 0. Okay, it could be loaded or not loaded. Yeah, if item 7 is loaded, item 5 must not be loaded. Okay, so meaning if x7 is equal to 1, x5 must be 0. Okay, so well, this should be x5 is less than or equal to 1 minus x7. Okay, because when x7 is equal to 1, right, when it is loaded, then 1 minus 1 is 0. So you're forcing x5 to be 0 because it has to be less than or equal to this. Okay, so now that we have that, we are now ready to do the Excel. Okay, so let's put this here. Let's put first the weight constraint. So the space shuttle can carry up to 2,600 pounds. So that means that okay. So it can carry at least 2,600 pounds. Okay, let me just take this one out. Okay, so we say equals sum product of this thing with the weights. Okay, it must be less than or equal to 2,600 pounds. And then, one item of group 1, so x5 plus x6. So we say that x5 plus x2 plus 5 plus x6 must be greater than or equal to 1. So we say equals x2 plus x5 plus x6. Okay, it must be greater than or equal to 1. Okay, next, for group 2 constraint, so we say x1, okay, plus x3 plus x4, okay, must be greater than or equal to 1. Next, x2, okay, if item 7 is not loaded, at least one item 2 must be loaded. So x2 must be greater than 1 minus x7. So say equals x2, okay, must be greater than or equal to 1 minus x7. There. Next, x6 should be greater than or equal to x7. So x6 must be greater than or equal to x7. Next, okay, if item 7 is loaded, item 5 must not be loaded. So we say x5, okay, it must be less than or equal to 1 minus x7. Okay, and now we need to get we are going to maximize the benefit here. So we say equals sum product of the total benefits. So this comma with this benefits here. Okay, now we can do the solver. So we just simply go with okay, so we do the solver, we go with data solver. Okay, so let's say we reset this one. There's something in there before. Okay, here we want to maximize the benefit. Okay, here maximize the benefit. This is it. Okay, we want to maximize it by changing these cells here, item 1 to item 7. Okay, subject to the following constraint. The first constraint is that, what's the first constraint here? The integer constraint. So 1, 2, 3, 4 is integer. So this one must be integer. Okay, then we can say add, and then 5, 6, 7 are binary. Items 5, 6, 7 are binary. Add, and then the next constraint is that the weight. So all of these are kind of like looking similar. The weight should be less than or equal to 2,600 pounds. Add this. Now the next one is that I can grab all of this at once, greater than or equal to this, and add. And then this one is less than or equal to that. Okay, and is there anything else? Okay, that's it. And we obviously you don't need to check this because we already, we can check this one because we want them to be non-negative. Okay, all right, so we solved the problem. So Excel is doing it. There it says it found a solution. Okay, and so okay, let's look at the solution here. So the solution would be 5 units of item 1 should be carried, 1 unit of item 6, and 1 unit of item 7. Okay, and with that it will satisfy all the constraint. Yeah, at least 1 on group 1, at least one in group 2, and then, this one exercise says, if item 7 is not loaded, item 2 must be loaded. Okay, so yeah. Okay, so this is fine because item 7 was loaded, so item 2 can be not loaded as well, right? You did not violate this. If item 7 is loaded, item 6 must be loaded. So as you can see here, item 7 is loaded, so 6 must also be loaded. If item 7 is loaded, 5 must not be loaded. So this one is loaded, so this one is not loaded. And the total benefit is 91. So that is how we do linear programming with logical constraints in here. So if we have integer decision variables, okay, or binary decision variables, and you need to put logical constraint like this, you kind of like need to think a little bit deeper. Okay, that concludes our session for today.